In this session, we are going to learn how to solve particle equilibrium problems. Let's start with a simple problem. Take a look at this example. Two workers are trying to place a heavy crate on the floor. The crate is supported by two ropes. Let's assume the mass of the crate is 100 kilograms. Rope BC makes an angle alpha with the horizontal. Rope AB makes an angle beta. At this instant, this crate is in static equilibrium. Our goal is to determine the forces experienced by these two cables. Before we go any further, I want to remind you something about cables. Cables, ropes, and wires work only on tension. In other words, I can pull a cable and generate a force on the cable, but we cannot push or compress a cable to support a load. This information is useful because when you see a cable or a rope, you now know the direction of the force. The force is always pulling or stretching the cable. This makes our life easier in solving problems. In solving static equilibrium problems, I want you to adopt a consistent approach. First, you want to identify what is given and what you need to find out in the problem. Second, you need to draw a free body diagram. Third, you must write the equations of equilibrium, and that is sum of all the forces equal to 0. Finally, you can solve the equations using any approach that you are comfortable. I highly recommend you learn how to use a calculator to solve the equations using a matrix approach. Let's now apply this approach to this particular problem. So in this problem, you are given the angles alpha and beta and the mass of the crate. Let's write this down. Alpha is equal to 30 degrees and beta is equal to 45 degrees. Since we want the weight of the crate and we are given the mass, we need to convert it. So let's convert the mass to weight by using the equation W is equal to mg. Now, we need to identify what are the unknowns. In this case, there are two unknown forces. Let's denote these two forces on the cables as T sub AB and T sub BC. Now, to solve equilibrium problems, we need to draw a free body diagram. Drawing a good free body diagram is the single most important step in solving statics problem. So let's take a closer look at drawing free body diagrams first. I am going to use a step-by-step process to draw the free body diagrams. Step-by-step approach will make it easier for you to solve any problem with ease. In order to draw the free body diagram, isolate the body or area of interest. The crate is in equilibrium, and if you look at the crate closely, you will realize there are three cables, and all we need to do is to draw the free body diagram containing these three cables. And these three cables are intersecting at point B, and let's identify this area. Now, draw an outline of the isolated part. This outline has got three lines coming out of point B. Each line represents the ropes. Now, let's show all the forces, both known and unknown, on this diagram and label them. You know force is a vector, and vector is shown using an arrow. In this case, the arrow will be going outward because the cables are always in tension. So we have now arrows representing the forces experienced by the three ropes. It's not enough just to show the arrows. We must give appropriate labels for the forces. In this case, I'm going to write T sub AB for tension in cable AB, T sub BC for tension in cable BC. And I'm going to write W for the weight. Weight is known and the two tensions are unknown. So here we have a diagram that shows all the forces. The next step is to show all the necessary dimensions. We need to write them down. The critical dimensions in this case are the two angles, alpha and beta. Alpha is equal to 30 degrees and beta is equal to 45 degrees. Weight is 100 kilograms, and we can convert that to force by multiplying by G, which is 9.81, and therefore the weight is 981 newtons. Finally, we always need an appropriate coordinate system to solve equilibrium problems. In this case, let us attach a rectangular XY coordinate system with its origin at point B. Please make sure you always draw a separate free body diagram. Do not ever draw a diagram right on top of the picture that is given to you. Now that your free body diagram is complete, we can write the equations and then solve. Let's write the equation. There is only one equation, sum of all the forces equal to 0. This is a vector equation. We can rewrite this vector equation as two scalar equations for each axis. Let's sum up all the forces along x-axis first. TAC times cosine 30 degree minus TAB times cosine 45 degrees is equal to 0. This is our first equation. Notice the negative sign for the force T sub AB because the tension is in the other direction. Let's now sum up the forces along y-axis. TAC times sine 30 degree plus TAB times sine 45 degree minus 981 is equal to 0. This is our second equation. So we have two equations and we have two unknowns. So we can now solve them using any approach. Let's solve this using our calculator and write down the answers.